The purpose of this video is to debunk a lot of the misinformation that we hear of in our industry regarding vacuum motors. We contacted the engineers at Ametek and we asked them two questions. Number one, is it true that there is a, quote, break-in time on the Ametek vacuum motors? If so, do they get, quote, more powerful than when they were new? Their answer was simple. Quote, there is no break-in point for the brushes. The break-in brushes are done at the factory and it only takes a few minutes. So when the motors are shipped and installed at that moment and you start using it, there is no such change. They will operate the same. So they do not become more powerful. The second question we asked is it true in regards to the 6.6 single stage or the 8.4 dual stage? Is it true that a two-stage under load will have better extraction and vacuum than a single stage? Their answer was simple. A two-stage vacuum motor is designed to have more vacuum than a single stage. The stages are rotating fans, and adding the extra stage in a two-stage vacuum motor allows more pressure and vacuum. Now that's the key when you're looking at vacuum motors. It's called pressure and vacuum to build up. So generally speaking, this two-stage vacuum motor does have more vacuum than a single stage. Now what we did is we took a competitive model single stage and we took our two-stage 8.4. Now number one, this is common sense. You can see the difference in size of the internal blades. Again, two fan blades, a single fan blade. So we selected two specifications here directly from Ametek. Now, these are the true facts that we want to debunk. Here on this particular model, single stage, you'll see the peak air watts of 717. Over here with our motor, you'll see air watts of 632. Well, isn't it true that more air watts are more powerful? No. Wait and see. All right, so now let's move down to what's our amp draw? Over here, we have 17.5 amps. So let's round that off to 18 amps. On our side, we're drawing 14 amps. That's a big difference when you're running a dual vacuum system in a home. Because remember, you're running other components as well. Now let's look at the CFM. Our competitor is running at 172 CFMs. Over here, ours is rated at 134. So, again, on the outside, remember, this is open. This is not under load. And remember what I just said from the engineer. You base it on pressure and when it's under load. That's the power of a vacuum motor. So, again, it seems like that competitive model 6.6, wow, that's stronger, isn't it? No, because here's the proof. As we move down the column of facts, we move into an area of, this is where it really gets under load. Okay, it starts to get under load. Over in our competitor side, we see that it's drawing 15 amps. On our side, we're drawing 13 amps. And you'll see that we're drawing on vacuum, inches of vacuum, 83 inches of vacuum. Again, I'm rounding it off. On their side, you see 80 inches of vacuum. I'll be darned. Ours is starting to take over. And it starts to take over all the way down. And let's get to optimum. On their vacuum motor, we see that they're drawing 115 inches of lift. We're drawing 142 inches of lift. I'll be darned. Which one is more powerful? That's exactly what the engineers told us, that a two-stage motor allows more pressure and vacuum to build up, and that's under use. That's the most important. So I hope that this debunks some of the misinformation going around on the boards.